In this video, we'll do a simple example that demonstrates how to use Simio stations, and we will use the add-on processes to implement the station logic. And so the example we're doing is a totally made-up example where we are decoupling entity arrivals from their availability for processing. So we're going to have random arrivals, and those random arrivals will be stored and then periodically moved into position to be processed. And the key concepts that we'll be using in this video are talking about Simio stations, continue talking about add-on processes, which we did in the previous video. In particular, we'll talk about the search step and user-defined events. And so let's take a look at the model that we'll be building. So let me just click Go to run. And what we have is random arrivals here, and periodically, every time an entity is created here, every 1 minute I believe, all of the entities that are in this location are moved to this location. And then on a different period, every 2.5 minutes I believe, all of the entities that are in this station are transferred to the processing area. We also have a user-defined event, and so I can click the S1 to S2 button at any time to initiate the transfer from station 1 to station 2. So specifically what's going on is we have a station defined here, station 1. We have a station defined here, station 2. We have a button which is tied to a user-defined event called event 1. And when entities arrive, they're transferred to station 1. Then we have a source which creates entities periodically every 1 minute. And when entities are created, all of the entities in station 1 are immediately moved to station 2. On a second period, entities are created here at this source, and when they are, all of the entities are moved from station 2 into the input buffer for server 1. Before we look at how we would build this model, we need to look at a couple of key concepts that we'll use in the model. First and foremost, what is a Simio station? Well, a station is an element that models capacity-constrained location for holding entities. And so, as we know, Simio models entities that exist in physical space. And so a station provides a location where I can store entities, and I can optionally have a capacity associated with that location. When we look at a server object, this server object from the standard library, we've already talked at length about the input buffer, the processing area, and the output buffer. And from an implementation standpoint, these are actually stations. So there's an input buffer station, processing station, and an output buffer station. And when an entity arrives to the server object, it's transferred into the input buffer, and then eventually transferred into the the input buffer station, then transferred into the processing station, and then eventually transferred into the output buffer station. And so in using stations, there are two things we have to keep in mind. We can use a transfer step to transfer an entity from its current location into a station, and then we use an end transfer step to signify the end of the transfer from one station to another. So we'll see in our add-on processes as we build the model, we will have a sequence of transfer, end transfer, then transfer, and end transfer. And in the standard library objects, much of the end transfer are done automatically, and many of the transfers are also done automatically within the processes that comprise the standard library objects. Okay, so let's have a look at how we would build this model. So we'll just start out with a new model here, and the first thing we're going to do is add our source object to create our entities, and we'll just use the standard inner arrival time properties and have them arrive according to the Poisson process. And so we also have our default entity, and when entities arrive, what we want to do is transfer them into a station. And so we need to first define that station. So I'm going to go to the model and the definitions, and we see our elements section here, and I'm just going to click on station and we'll just leave the default name of station 1. So we've now created a station, and what we want to do is when entities enter the output node, we will create an add-on process that simply transfers them into the station. So I'm going to click on the add-on process triggers and use the shortcut. So I'll just double click on the entered and add the process. And so when a entity enters the output buffer, I want to transfer immediately from the current node, as we did this when we have the add-on process when it enters the output, and this time we want to transfer to a station. And so the transfer to type is station. So we will transfer from the current node, which is the output of source 1, to a station, and we want it to go to station 1. Now, we also know that when an entity is transferred into a station, we have to manually end the transfer. So I'm going to create a new process by clicking on the Create Process button, and it creates a process named Process 1, and I'm simply going to add the end transfer. Now, we have a process that ends the transfer, and we need to tell Simio at what point do we execute that process. And so I'm going to select the process, so I move away from any one of the steps and just click, and you see the hatch line. So I've selected the process, and I'm going to go over to the triggering event name property, click on that, and select station 1 entered. And so now we see the little lightning bolt symbol here with station 1 dot entered, and that tells us that this process is executed when the event station 1 entered occurred. So if we look at our model, we have entities that arrive randomly, source 1. When they enter the output node, the process output underscore source 1 underscore entered is executed. That initiates a transfer from that node to station 1. When station 1 is entered, Simio will automatically fire an event called station1.entered, at which point we simply end the transfer. So if we go back to our model, now I want to display that the contents of station 1, so I'm going to go to the animation ribbon and just select detached queue. And now I'll draw a detached queue here. And the queue state property defines the queue that the detached queue that I'd like to animate. So I'm going to go down to station1.contents, and station1.contents says show me the contents of the station 1 station. And so now when I run my model, we can see that when entities arrive, they're immediately transferred into the station. Now our model doesn't do anything else, so if we continue to let our model run, the station will just continue to build. Since we didn't put a capacity, since we didn't specify a capacity, this would just run until we exceeded the maximum number of entities in the system. So the next step we're going to do is add station 2. So recall that when entities arrive randomly, they're placed in station 1, and then periodically we will transfer them to station 2. So I'm going to go to my model, definitions, and create station 2. Again, we'll just leave the default name. Then I'm going to go back, and I'm just going to copy the animated queue, so I can just use the Control-C to copy it to the clipboard, and the Control-V to paste it. And then I can just go over and change the property from station1.contents to station2.contents. The next thing I'll do is I know that I have to end the transfer, and so this is something that when I'm doing models like this, I often forget. So I try to do it as soon as I create the station. I go ahead and create the process to end the transfer. So I'm going to do that. Call it process 2. We'll just leave the default name, and I want this process to execute when station 2 is entered. So it's identical to process 1, except it happens when station 2 is entered. So now we have our 2 stations, and we need the logic for pulling all of the entities out of station 1 and transferring them to station 2. That's the thing that we want to happen periodically. So I'm going to do that with an add-on process. I'll go create add-on process 3, and again we'll just use the default name. And essentially what I need to do in this process is pull everything out of station 1 and transfer it to station 2. So before I do that, I'm going to add an additional symbol to our default entity so that we can change its color as it moves from station to station. So go back to our process. Here we have process 3, and we'll use the search step, and over in the properties we specify the collection type as a queue state. So I'm telling Simio I'd like to search the queue state, and I want selection 1 contents, and so this is saying search the queue state selection 1 contents, and we're going to leave the remaining basic logic to its defaults, and I'm going to open the advanced objects, and there's a limit, and if you click it, it says the maximum number of items to find. It defaults to 1. We want everything, so we'll change that to infinity. And so when the token executes the search step, it pulls everything out of station 1 contents because we have this set to infinity, and all of those the tokens representing those entities come down the found branch of our search. So the first thing I'm going to do is change their color. So I'm going to go to assign and say model entity dot picture and set the value to 1. Default is 0, and then I'm simply going to transfer this time from the current station, which will be station 1, to station 2. So the process says when this process is executed, search the queue state station1.contents, and with everything you found, with each entity that you found, set the picture to 1 and transfer it to station 2. And recall that when an entity enters station 2, Simio automatically fires the station2.entered event, which then executes process 2, which in turn ends the transfer. And so if we go back to our model, that should achieve what we want. Now what we haven't done yet is specified when to execute process 3. So I said earlier that this was an add-on process. As of now, all we've created is a standalone process. So before we create the periodic entities that will pull the entities out, let's go ahead and specify how we do the button. So what I want to do now is create a user-defined event. So I'll go to Model, Definitions, Events, and just click on the event button on the ribbon, and it creates an event called Event 1. Then I'll go back to my processes and say I want process 3 to execute when Event 1 fires. So now we have the lightning bolt symbol saying when Event 1 fires, or when Event 1 occurs, execute this process. Go back to our facility to the animation ribbon, and we have a button here. So we'll just place the button, and then in the property we'll specify Event 1. So our button says, or our button logic says, when you press the button, fire Event 1. When Event 1 is fired, then we should remove everything from station 1, transfer it to station 2, and the transfer will be ended. So we'll let it run for a little while as we build up a couple of entities in station 1. When I click the button, note exactly what we thought was going to happen. We remove all the entities from station 1. They change color because we've increased the symbol index, and placed in station 2. So now that we can remove entities from station 1 and place them in station 2, basically on command using the button, we want to generate the periodic pull. So we're going to create another source, and I'll just go directly into a sink and put the path here. And so I want this to happen on a fixed period. So I'll go to the properties and say, let's make the time offset 1 and the time interval also 1. And so every 1 minute, starting at minute 1, we're going to pull all the entities out. And so I'm going to do that using an add-on process to the output node, and when an entity enters the output node of source 2, I'm simply going to execute process 3. So in this case, I didn't create a new add-on process, but instead I applied an existing add-on process and set the trigger to that particular process. So now when I run, every 1 minute we're going to create an entity out of source 2, and so the net result is that every 1 minute everything that happens to be in station 1 will be automatically moved to station 2. And finally, to finish our model, we'll put our server. So we have a server here, and we'll place a sink for entities once they complete processing. And what we want to happen is on a second interval, I want to pull entities out of station 2 and send them directly to the server. So I will put down another source and another sink, just as we did before. And the cycle that we want to use here for this one doesn't really matter, but let's use 2.5 minutes. So we'll do the same as we did with the previous source. We'll set a time offset to 2.5, and we'll set a interval time to 2.5. So at the end of source 3, what we want to do is we want to pull everything out of the station 2 and send it to server 1. So at this point we don't have a process to do that, so we'll go into the processes and create a fourth process, and process 4 is going to look almost exactly like process 3. So I'm just going to highlight and use copy and paste that, the search, and instead of searching station 1, I'm going to search station 2. I'm going to assign, but this time I'm going to assign modelEntity.picture a value of 2. And before I forget, I need to go back and do that. So I highlight my entity, add a symbol to get to my third symbol, and then we'll make it a different color also. So we'll make this one light blue. So we go, and now our default entity has 3 symbols: the green one, the red one, the blue one. And in process 4, we search all of the contents of station 2, we increment the picture, and then we do a transfer. This time we're transferring from a station, current station, to a node. And the node we want to transfer is the input at server 1. So instead of going station to station, which we did in process 3, we'll go station to input at server 1 for process 4. Then we go back, and the output for source 3, we will have an add-on process trigger saying assign to process 4. And so now every entities arrive randomly. Every 1 minute we should take all of the entities from station 2 and put them in station 1 and put them in station 2. Every 2.5 minutes everything should go from station 2 to server 1. And so let's see if that's in fact what happens. So we grabbed everything from station 2, and now everything goes from station 2 to the server. And so we've effectively implemented the model that we specified in the beginning. Again, this model doesn't really do anything. I haven't come up with a context for it. Instead, we wanted to just demonstrate the use of semiostations, continue our exploration of add-on processes, and it turns out that in the general modeling context, this ability to store in detached queues and extract or pull from those queues sort of on demand when conditions in the model warrant it, turns out to be quite powerful and quite useful.